Let's start pre-processing. I won't dive into the code too much, as we want to focus on machine learning as much as possible. You can later examine the code with comments or ask a question in the Q&A section to get a better understanding. As usual, I'll import NumPy as NP. Next, from sklearn, I'll import preprocessing. Let me stop for a second. I'll use the sklearn capabilities for standardizing the inputs. It's one line of code which drastically improves the accuracy of the model. Almost always, we standardize all inputs as the quality of the algorithm improves significantly. Without standardizing the inputs, we reach 10% less accuracy for the model we will build here. And you remember how a 0.5% improvement in the MNIST example was a great success. We suggested installing sklearn when we were setting up the environment in the third section of the course. It was also one of the exercises. If you don't have it installed yet, I suggest installing the package following the well-known methodology. Let's get to work. First, I'll load the CSV file. So, raw CSV data equals np load.txt audiobooks data.csv with a comma delimiter. Okay, now we have the data in a variable. Our inputs are all the variables in the CSV except for the first and the last column. The first column is the arbitrarily chosen ID, while the last is the targets. Let's put that in a new variable called unscaledInputsAll, which takes all columns, excluding the ID and the targets. So, the 0th column and the last one, or minus first. Let's record the targets in the variable targetsAll using the same method. They are the last column of the CSV. Cool! We have extracted the inputs and the targets. The next section of code will deal with balancing the data set. We will count the number of targets that are ones, as we know they are less than the zeros. Next, we will keep as many zeros as there are ones. Okay, let's count the targets that are ones. If we sum all targets, which can take only 0 and 1 as value, we will get the number of targets that are ones. So, number of 1 targets is equal to NP, sum of targetsAll. I'll declare it as an integer, as targetsAll may be a Boolean, depending on the programming language. Then, I'll just keep as many zeros as ones. Let's set a counter for the 0 targets equal to 0. Next, we will need a variable that records the indices to be removed. For now, it is empty, but we want it to be a list or a tuple, so we put empty brackets. Let's iterate over the dataset and balance it. For I in range targetsAll dot shape 0 semicolons. TargetsAll contained. All targets. Its shape on the 0 axis is basically the length of the vector, so it will show us the number of all targets. In the loop, we want to increase the counter by 1 if the target at position I is 0. In that same if, we put another if, which will add an index to the variable indices to remove, if the 0's counter is over the number of ones. I'll use the append method, which simply adds an element to a list. So, after the counter for zeros matches the number of ones, I'll note all indices to be removed. Okay, so after we run the code, the variable indices to remove will contain the indices of all targets we won't need. Deleting these entries will balance the dataset. Okay, let's create a new variable. Unscaled inputs with equal priors, which is equal to np delete of unscaled inputs all, from which I want to delete the entries with indices from indices to remove on axis 0 of the vector. Similarly, The targets with equal priors are equal to NP delete of targets all, indices to remove on axis 0. Done. All right, we have a balanced data set. Next, we want to standardize or scale the inputs. The inputs are currently unscaled, and we noted that standardizing them will greatly improve the algorithm. A simple line of code takes care of that. Scaled inputs is equal to preprocessing dot scale of unscaled inputs equal priors. That's the preprocessing library we imported from sklearn. The scale method standardizes the dataset along each variable. So basically, all inputs will be standardized. Cool! So, we have a balanced dataset, which is also scaled. Our preprocessing is almost finished. A little trick is to shuffle the inputs and the targets. We are basically keeping the same information, but in a different order. It's possible that the original dataset was collected in the order of date. Since we will be batching, we must shuffle the data. It should be as randomly spread as possible so batching works fine. Let me provide a counterexample. Imagine the data is ordered, so each batch represents approximately a different day of purchases. Inside the batch, the data is homogeneous, while between batches, it is very heterogeneous due to promotions, day of the week effects, and so on. This will confuse the stochastic gradient descent when we average the loss across batches. Overall, we want them shuffled. Let's see the code. First, we take the indices from the axis 0 of the scaled inputs shape and place them in a variable. Then we use the NP random shuffle method to shuffle them. Finally, we create shuffled inputs and shuffled targets variables equal to the scaled inputs and the targets, where the indices are the shuffled indices. All right. So far, we have preprocessed the data, shuffled it, and balanced the dataset. What we have left is to split it into training, validation, and test. Let's count the total number of samples. It is equal to the shape of the shuffled inputs on the 0th axis. Next, we must determine the size of the 3 datasets. I'll use the 80-10-10 split. Trained samples count is equal to 0.8 times the total number of samples. Naturally, we want to make sure the number is an integer. Next, the validation samples count is 0.1 times the total number of samples. Finally, the test samples count is equal to the total number of samples minus the training and the validation. Cool. We have the sizes of the train, validation, and test. Let's extract them from the big data set. The train inputs are given by the first train samples count of the preprocessed inputs. The train targets are the first train samples count of the targets. Analogically, the validation inputs are the inputs in the interval from train samples count to train samples count plus validation samples count. The validation targets are the targets in the same interval. Finally, the test is everything that is left. Cool! We have split the dataset into training, validation, and test. It is useful to check if we have balanced the dataset. Moreover, we may have balanced the whole dataset, but not the training, validation, and test sets. I'll print the number of ones for each dataset, the total number of samples, and the proportion of ones as a part of the total. They should all be around 50%. Let's quickly run that code. We can see the training set is considerably larger than the validation and the test. This is how we wanted it to be. The total number of observations is around 4,500, which is a relatively good amount of data, although we started with around 15,000 samples in the CSV. The proportions, or should I say the priors, look okay, as they are almost 50%. Note that 52% or 55% for two classes are also fine. However, we want to be as close to 50% as possible. Okay. Finally, we save the three datasets using the NP saves method. I name them in a very semantic way, so we can easily use them later. All right, our data is pre-processed now. Each time we run the code, we will get different proportions as we shuffle the indices randomly, so training, validation, and test datasets will contain different samples. You can use this same code to pre-process any dataset where you have two classes. The code will skip the first column of the data, as here we skip the ID, and the last column will be treated as targets. If you want to customize the code for a problem with more classes, you must balance the dataset classes instead of two. Everything else should be the same. The pre-processing is over. Henceforth, we will only work with the NPZ files. I will save this Jupyter notebook and continue with the machine learning in a separate one. Make sure that you have the raw CSV when you run the code on your computer. In this way, you will create the NPZ files, which we will use for the machine learning part. There are some additional adjustments you can make the code to improve the pre-processing. Check out the exercises and work on them if you'd like. Great work! Next time, we will take care of batching. Thanks for watching.